would be example 1. And before example 1, just a review of how to graph lines. So I have 2 methods here. One is where you use the point and the slope. Is this big enough? Should I make it bigger? Bigger? Whoa, bigger and fatter. There we go. Let's do this one first. Okay, review graphing lines. These are your methods for graphing lines. You can change things to your y equals mx plus b form, because then you can use this point, which is your y-intercept, and your slope, which is rise over run. So you start with your y-intercept, then you go up 3 over 1 and find another point, up 3 over 1, or whatever the slope is. And that would allow you to graph it because you'd get a bunch of lines. A second method, you just have to find 2 points to graph a line. And I say 2 or more because I usually like to try to find 3 points on a line, because then I know if all 3 line up, then I haven't made a mistake. But if I've made a mistake and my 3 points don't line up to be a straight line, then I have to check and see which one went wrong. So I say find 2 or more points. Sometimes your intercepts, your x-intercept and your y-intercept, are great points to find to graph a line. You can make a table of values to find as many lines as you want. Then you just have to draw your line. The review of inequalities. The main thing from inequalities that you need to know is you solve inequalities the same as equations. So what you do to one side of the equation, you do the other. However, if you multiply or divide by a negative number, then your inequality gets flipped. So you remember that from last year. That's the main thing that's different with inequalities from equations. That one additional rule. Are we ready? Almost. Step 1 says use a point and slope, change to y equals mx plus b.
Point or slope? Or?
Point and the slope. So use the point and the slope. When we do our first example, I'll show you both methods for graphing the line. Our first example will also involve having to flip the inequality, and so we can do a number of.
Sorry for the interruption. If we could please have the last batch of grade 12 students to please make their way to the cafeteria with the last name starting with the letter N through to the letter Z, and any other grade 12 students that have not picked up their report cards yet. If you could please go to the cafeteria to do so. Thank you.
Okay, so here's our first example. If I want to change this to y equals mx plus b form, I'd have to subtract the x on both sides. So then I would get negative 3y is greater than negative x plus 6. And if I wanted to get the y by itself, I'd have to divide everything by 3. Now when I divide this side by...
Excuse me.
Hello?
I said Haruki, Yamashita, Leo Dombrowski, and...
I got negative 3y greater than 6 minus
6 minus x or minus x plus 6 would be the same thing. Just depends on where you put it. I put the minus x first just because it's more closely like y equals mx plus b. So now if I divide the whole right side by negative 3 as well, it's like dividing each of these things by negative 3. So in the end, I'm going to get y. Now, our special rule comes into effect right now. We just divided by a negative, so our sign is going to flip. This is going to be positive 1/3 x, because a negative divided by a negative is positive. And 6 divided by negative 3 is negative 2. So this is changing to y equals mx plus b form. We now know that our y-intercept is at negative 2. Our slope, remember this is your rise and this is your run of your slope, means that we need to go up 1, then over 3 till we get to our next point. Up 1, then over 3 to get to a next point. Will I draw a solid line or a dotted line in this one? Dotted. This is going to be the hardest thing for, well, it's the hardest thing for me. I get so excited about drawing the line that I just draw a solid line and then I look and I go, oh, I have to make it dotted. Then I have to erase my line and make it dotted afterwards. Yeah, that's usually what I do, have to do too, just erase little parts of it. So it's a dotted line. In the end, when we changed it to y, we have less than, so our shading is going to be below. Ooh, I like to use crayons while shading. Oh, nice. A crayon. Isn't it? Oh, it's just fun to shade with crayons. Okay, so that is the graph. That's using the y equals mx plus b. You could also graph this finding your intercepts, like find 2 points. And then you could use your equation right at the beginning. How do I find an x-intercept? Make y equal to 0. Can you see that if you make y equal to 0? Now, we're finding an actual intercept, so I'm going to just use crayon. I don't know what happened there. I'm going to just make it equal to 6 because I want to find exactly where that x-intercept is. Well, can you see that's just going to be x equals 6? That's this point right here. We had already found that with the other method as well. Your y-intercept, you make x equal to 0. So if I go 0 minus 3y equals 6 to find my y-intercept, I'd have to divide both sides by negative 3, and I'd get y equals negative 2, and that would be this point. So in this case, finding your intercepts was really quite easy, and we could have got this same dotted line with that method as well. The problem with just finding your intercepts is it doesn't tell you where to shade right away. The shading part, when I have y less than, I know I can shade below. There is another way to find out how to shade, and that's using test points. Did Ms. Halaz talk about test points at all yesterday for shading? All it is you pick a point above your line or below your line. Often I like to pick points that involve 0. I'm going to choose 0, 0. I plug that point in and see if it's true or false into my original equation. When I plug in 0 for x and 0 for y, and I simplify both sides, on the one side I'm going to get 0. On the other side I still have 6. And you ask yourself, is 0 greater than 6? True or false? No. That is false. And since our test point was above, and that was false, it tells us to shade below. If you had chosen a test point, let's say you had chosen this point right there, that point is 0, negative 4, right? If I had chosen that as a test point, wow. And 0 for x minus 3, negative 4 for y, is that greater than 6? That becomes 12. Is 12 greater than 6? True. So if your test point was true, then that would mean you'd shade the place where the test point was. If your test point is false, you'd shade the other part. So that's how you can use test points if you want to check which sections are true and which ones are false. Well, is 0 greater than 6? False. And that tells us that this point isn't in the solution, but the bottom part is. So that was example 1, and she told you the questions 3, 4, 5, and 7.